Okay.
Yep, I will.
Okay, perfect. Thank you. All right. It's 2 o'clock, so I'll go ahead and get started because we have a little bit of a tight schedule. So welcome to our Energy Research Spark Talks. And so this is an event part of Energy Week 2021, and it is sponsored by the Student Energy Club at NC State University. And so I just wanted to give a quick overview of the schedule. So for about 5 minutes, we'll just give a quick introduction to the Student Energy Club and some of the opportunities should you wish to be part of the club. From 2:05 to 2:30, we'll have the Spark Talk research presentations. And then from 2:30 to 2:50, we'll have the questions and voting. So please just you can put your questions in the chat but we'll answer them at the end. But feel free to go ahead and put them in the chat as the presentations are being presented. And you can also use the question answer tool. Either one's fine. And then in the sign up, we gave the opportunity, if you wish, to meet the presenters after the presentation. So from 2:50 to 3 p.m., if you indicated that either yes, you would like to meet the presenters, or maybe you're interested, we will, if you stay on, we'll go ahead and transfer you over to a panelist so you can talk directly to them and learn more about their research. So I just wanted to give a quick advertisement for the last Energy Week event tonight. So Energy Week's really exciting. We've had lots of events all week, and this is the second to last event. And the very last event is the Reverse Pitch Careers in Energy and Clean Tech. So if you're interested, you can just search for NCSU Energy Week, and you can sign up there. So this will be the last event of Energy Week 2021. And I should mention, Energy Week is an annual event that occurs every year, is sponsored by multiple organizations at the NC State University campus.
So as previously mentioned, can y'all hear me all right? All right, nice. As previously mentioned, we're the Student Energy Club at NC State. Our mission statement is to try and educate the focus being NC State students and then the surrounding area on energy problems and solutions, and basically all about the energy space. As mentioned, Energy Week is a yearly event that we do, whole week dedicated to events and webinars talking about energy solutions, any problems. Oh, can you go back a bit? Yeah, our main flagship program is our webinars and seminars. We have panel discussions where you can interact with a host. We also do numerous outreach and networking events, such as showing movies, tabling at events, etc. And then if you want to join our mailing list, there is the QR code right there. Some of you are already on it, but in case anyone else wants to be on it, there you go. And then I get, yeah, there we go. Emily, do you want to talk about the program?
Yep. So with the Student Energy Club, we have a mentorship program that basically connects undergrad students or anyone who's interested in grad school with a mentor. And this can be a current graduate student or professor or someone who's currently working in the energy industry. And you can just ask questions about how to get into grad school, energy research that's happening on NC State campus, different types of career opportunities. And it's just a good way to get those questions answered, especially if you're not actively involved in the energy space already, or if it's just something that you're looking to get more involved in. Yeah, that's about it.
And lastly, we have a few leadership opportunities available if you want to come and join the team. Our current desire is a chair of event planning, but if you're open to other positions and think you can help out in another way, we are more than happy to have you. We do have our applications going on a rolling basis, so no worry about missing a deadline yet. And if you want to apply right now, go ahead and scan this QR code or get it loaded up for after the presentation, since we want you paying attention to these fine people.
All right, thank you, Hayden, Emily. So this will be the presentation order, and the way it will work was each of the presenters will share the screens one after each other. I'll also be presenting my research, but not competing in the competition. And at the end, we will have questions and voting. So try to keep in mind, you can vote for the top 3 presentations, and we'll have for People's Choice. So we'll have both People's Choice Award, which we will have the Google form to vote in the chat after the presentations, and you'll be able to vote for your top 3. And then we'll figure out who has the most votes for People's Choice Award. And then we will also have official judging for the best presentations, and we will announce the winners by email after the event. And like I already mentioned, you can put your questions in the chat as the presentations are going, but we will address them at the end. So we'll go ahead and have Matthew Phillip share his screen.
All right, am I in presentation mode? Or, oh, there we go.
Not yet. Okay, there you go.
Okay. Ready for me to start? Okay. All right. Hi, everyone. I'm happy to share a snapshot of the photovoltaic research that I've been conducting with Sandia National Laboratories as an intern. Solar cells see a wide range of environments in their use, many of which can contribute to premature failure. Unfortunately, the photovoltaic community doesn't have a great understanding of how events like heavy snow, high-speed wind, hail, or even animal encounters have on a module's durability. The characterization of a module is then left to standardized tests like pressure loads on top of cells, or some more unconventional means like electroluminescence imaging and a curious researcher. These tests, however, do very little to inform manufacturers how the modules will experience any kind of stresses in the field. So we sought out to obtain in situ measurements of a module's mechanical state by laminating strain gauges inside of a module. The idea is that if these strain gauges can accurately represent the mechanical state in a controlled environment, they can also provide real-time measurements in the field. To test this hypothesis, 4 modules were constructed. One was left alone as a control, and the other 3 were instrumented in various configurations. Each one was then mounted to a pressure chamber that applied a uniform pressure load to the surface of each module, and optical sensors were placed in the back to monitor the displacement field. My task then was to validate these experimental results using a high fidelity finite element simulation. One important modeling consideration is always the material models that you select for each component. The encapsulant layer of a module is really interesting because it protects the silicon cells, which are brittle, from fracture. And it's often modeled as an elastic material. However, it's more accurately represented as viscoelastic. So in the literature, we found a material model for this material, and we wanted to validate its response by a stress relaxation experiment. And we did that in Sierra, a modeling tool, and the results agreed closely with literature. So we felt comfortable including it in the photovoltaic model. Another interesting or important consideration for modeling is the application of boundary conditions. From the 4 experiments, we then averaged a uniform pressure load that I simulated then for an identical comparison. Our results showed that both the displacements and the strains obtained in the module matched the trends that we saw in the experiment. However, the magnitudes of these were lower than we had hoped for. We determined several reasons why this might be the case, and we will run future simulations to hopefully more accurately represent the physical experiments. If we're successful, then we hope that in situ measurements will be obtained in the field and will help accelerate the development of next generation photovoltaic modules. Thank you for your time.
Thank you, Matthew. If now Harleen can share her slides.
Yeah. Okay, I'm gonna start. By the year 2040, the demand for electricity is expected to rise by 40%. But if we want to reduce carbon emissions, we cannot keep relying on coal and gas power plants. Therefore, to achieve a greener future, two huge steps need to be taken. One, generate clean energy using renewable sources or nuclear power. Two, the ability to match the demand and the supply. Currently, due to storage issues, the renewable energy cannot keep up with this ever-rising demand for electricity. Therefore, we need nuclear power. Now, there is some negative hysteria around nuclear energy. Whenever I talk to my friends about nuclear power, 95% of the time they say, oh my God, nuclear will blow us up. Clean energy also needs to be safe for public use. Current statistics have shown that we are 1,000 times more likely to die from choking on our food than from a nuclear accident. What's more, with ongoing research towards microreactors and artificial intelligence, we can have small, safe energy-producing units for cities, towns, and even communities. One such project is being conducted at NCSU for the autonomous control and management of nuclear reactors. As a part of this national level project, I have built an artificial intelligence framework that assesses the health and condition of nuclear structural systems. With my AI framework, I can detect any damage or degradation, as minor as it can be, and inform nuclear operators during their daily inspections. Using this AI framework, we can detect damage early on, and that saves two main purposes. One, it increases the safety of the nuclear power plant. Two, it saves millions of dollars. But how? Current inspection techniques require nuclear power plants to be shut down for several days, and this results in a huge loss of revenue. To reduce this loss of revenue, close to $1 million a day, my AI framework running 24/7 continuously can keep providing key essential information to current inspection techniques, thereby saving them a lot of money while preserving the integrity of the nuclear power plant. With higher investment opportunity and trust in nuclear energy, I believe we can build more nuclear reactors to match the rising demand with the supply, and also to open pathways for other green energy. Thank you.
Thank you, Harleen. Let's see. Can Xian please share her slides?
Yes, let me share this screen. Can you all see my slides in the presentation mode? Okay, cool. Hello, everyone. My name is Qian Luo, and I'm a PhD student at Environmental Engineering. Thank you all for being here today. Spoiler alert. My project is diverse pathways for power sector decarbonization, yield health co-benefits, but fail to alleviate exposure inequities, which has almost summarized everything in this work. But still, I will provide some background information first. Climate change has profound implications almost on everything. The power sector is an increasingly big source of carbon emissions. So we set a goal to reach carbon-free electricity by 2035. However, decarbonizing a power grid can never be cheap. The cost effectiveness is important in determining which pathway we should follow. But one question here, what should we consider when measuring the cost effectiveness? Except for the climate benefits, decarbonization also yields benefits in human health. With reduced electricity generation from the burning of fossil fuels, a lot of air pollutants released from the smokestack also decrease. Here, I focus on SO2 and NOx that form fine particles in the atmosphere that inhaled by us, which is currently the greatest human health risk. Scientists have developed an approach to quantify and monetize the health impacts caused by those fine particles so that we can compare the costs and the real benefits. All decarbonization pathways developed in this project prove that the health co-benefits far exceed the actual cost to implement the pathway. Everything seems perfect, right? But do you still remember the second part of the spoiler? Will this decarbonization pathways lead to a just energy transition? Unfortunately, none of them reduce the exposure disparity. Let's look at the income first. Total population was divided into two groups. The black bar on the far right is the population fraction, and the color bars are the health damage fraction received by the group under different pathways. If the color bar is beyond the black bar, like people living in low-income tracts, the group is suffering from disproportionately more exposure. The disparity also exists across races. White populations receive fewer damages than Hispanic and the Black population. This project didn't find a perfect solution to this issue, but it at least highlights the need of environmental justice analysis when implementing any carbon decarbonization strategies. That is all about my work. I'm happy to take any questions at the end. Thanks.
Thank you, Chen.
Let me stop sharing. I couldn't find my notes. Here's.
Do you see the stop share?
Yeah.
Okay.
Can you guys hear me?
Yes.
Okay.
Your presentation's still loading. Okay, there you go.
Okay. So my name is Shamik Bhattacharya. I'm an undergraduate student at NCSU. This is actually a paper that I wrote last year in a natural resources market class. So basically on carbon offset markets. So carbon offset positively affect global warming. So industry leaders are offsetting their carbon dioxide by investing in green projects. So carbon markets are actually divided into two markets. You have the mandatory market on this side and then the voluntary market on that side. Since we're de facto economists, we always have to talk about costs. So what's the relevant potential cost of production, the relevant potential revenues, and the profitability. So the first bullet point, it depends on both landowners who are the producers and the buyers who are the consumers on, the costs. For the relevant potential revenues, landowners / companies can profit when they're dealing with the forest. So for example, in year zero, and I have a thing on slide number 3 that explains this, landowners or producers are going to pay a certain upfront cost to their carbon project. I'm going to move you guys over here. So for profitability, it's very profitable under the voluntary market, and under the compliance market, it's maturing, but there are still rewards. The projected market value size is from 5 to 30 billion and even 50 billion by 2030. Some examples of compliance and mandatory markets are the Kyoto Protocol, the EU transition, or the ETS, California Air Resource Board, and the voluntary markets is the Chicago Climate Exchange and other ones. Here's some cool images that I found on the net just on carbon offsetting, countries, just an image. God. 1 second. Nope. I'm sorry.
That's
No
okay.
problem.
Come on.
Having only in presentation mode.
Yeah, I can't even find my slides anymore.
Do you want me
Okay.
to share from my computer or?
Yes, please. Yes, please. I'm so sorry.
That's okay.
All good.
Yeah, I was on the third slide. Yes. So on the left side of your screen, you'll see General Motors, and they actually have been top in buying offsets for at least, this was in 2015, and they've been at the top of the voluntary market. And on the right side, depending on where you live in the US, this is how much the first year revenue you might get from carbon offsetting, and then annual income. And then this is my sources, which was a guest lecture from the NR 219 class. Thank you so much, and I'll be happy to take any questions later.
Okay, thank you very much, Shamik.
Yeah.
Stop share. Okay, if Christina can go ahead and share her slides.
Hi, can you hear me good? Yes, okay. Okay, then hello everyone, good afternoon. Thank you very much for this opportunity to presenting the IRTEMS project here during the Energy Week. So IRTEMS, or Instantaneous Road Traffic Emission Modeling for Cities, is a 3-year currently ongoing project funded by the European Union. It is coordinated by the Universidad Politécnica de Madrid, located in Spain, where I come from, and is in collaboration with the NC State University. So the project focuses on road traffic, since this sector continues to be one of the main contributors to emissions. On the emission of air pollution in many cities around the world. And this is a very relevant source, especially in cities, because there is where people and the emission source are interacting. So this is a especially important factor for that. So to understand the spatial and temporal distribution of the emissions, typically regional traffic emission models are used for the compilation of urban inventories. And nowadays, these are usually the most detailed data available at city scale. But this level of detail is not enough to understand the high pollutant concentration that occur on specific urban environments, also called hotspots. Okay, so to accurately understand the influence of this very local high concentration on the real exposure of the population, there is a clear need to estimate the contribution of road traffic to atmospheric emission at city level, but within grid detail. So for that, an integrated multi-scale approach is needed. Here in this picture, we can see an example of Madrid City, which is my city in Spain, where by using macro scale tools, road traffic volumes can be estimated in the main roads. These are the green and orange and red lines that we can see in the figure. But to understand the traffic dynamics on specific so the traffic dynamics and the related emission of this traffic on specific points, like the ones I choose, there are 2 ones, we need much more detailed information on these specific points. So to achieve this goal, IRTEM aims at developing an instantaneous road traffic emission modeling system that could be applied at city scale. This integrated approach will provide citywide traffic emission estimation with high resolution in time and space. And this will be useful to understand the real implication of air quality policies and to analyze the potential of local abatement measures. So in conclusion, with this modeling system, we will be able to analyze road traffic emission at city scale, but with enough detail. And this is crucial to make knowledge-based decisions to improve air quality in our cities. So if you want to know more about the project, you can visit us on our webpage or also on ResearchGate, or contact me if you want by email. I will be happy to respond to any question that arise. Thank you very much. This is all for me.
Thank you, Christina. Can Amir please share his screen?
Okay, can you see my slides? No, not yet. Okay, no.
Let's see. It's not in presentation mode though.
Yeah. Let's share the screen. Okay, now it should be good. Yep, okay, great. So as you know, about 50% of our electricity comes from the fossil fuel resources. So the question here is that how much air pollution are these power plants contributing? So, and how much does it cost? I mean, what's the human health cost of this pollution? For a study here, we are focusing on CAISO, which is California Independent Power System. And we are modeling that system to see, is there any policy tool to reduce that health damages? And how much, what's the situation that those policy tools lose their effectiveness? To do so, we are using the historical data, which is the stream flow, air temperature, wind speed, and irradiance, and converting them to 500 years of stochastical weather data, and use those data to predict the hydropower generation, demand, wind power, and solar power generation, and feeding them into the unit commitment economic dispatch model. With that model, we can predict the electricity generation of each power plant. Using those data, we can predict the market price, amount of emission, and other stuff. The thing that we are trying to prove is that we can use emission taxes to reduce the amount of health damage, which is basically reducing the emission at the points that are mostly needed. So our basic results show that what we see on top here in the first row, this is the electricity demand distribution during the year in California for those 500 stochastic years. So as we see during late spring to early fall, we have high demand, and at the same time, the local air damages is higher. But if we look at the prices, we see some spike in price, but the average price is kind of consistent throughout the years. If you look at this bottom correlation matrix, but some of the important points here is that the local damages is negatively correlated with hydropower, which basically means that the lower the hydropower, which is the drier the year, we are going to have more damages. And also we see a negative, a positive correlation between the local air damages and racial inequality, which basically is saying that the minority groups are receiving more damages. But then what's the reason and how can we, what can we do about that? As you see here, the drier year on the bottom, we have the worst year, which is the highest damage year in those 500 years, is a dry year. But we don't have any idea here about the other effects. If we zoom in on the effect of taxes, so this big plot here is the daily damages on the x-axis, and the y-axis is the amount of reduced damages using taxes or penalties. We see that by increasing the daily damage, the amount of damage prevention, we see here a drop. And that drop is when our policy stops working. If we look at these different zones, zone D is the one that we don't see. We see our policy effectiveness is dropping. And those are late summer days, which are basically hot, and we have high load, and we can't do anything. If we zoom in on power plant scale, as we see during those days, we have very high demand and we don't have enough generation in reserve to use the cleaner power plants to reduce the amount of emissions.
Thank you, Amir. All right. Hi, everyone. I'll be presenting on, do the health benefits of boiling drinking water outweigh the associated impacts of increased household air pollution exposure? Water and air are the two of the biggest environmental health risks. So this map shows the premature deaths from unsafe water, sanitation, and hygiene. Globally, 1 billion people lack access to safe drinking water supplies, resulting in 1.7 million deaths annually. And this map shows the global indoor air pollution premature deaths. 2.8 billion people cook using solid fuels, resulting in 2.6 million deaths annually. Boiling is the most common household water treatment method, with an estimated 1.2 billion users, or 70% of all household water treatment users. However, boiling often takes place with solid fuels. So the objective of this project was to model the health trade-offs from boiling drinking water with solid fuels. And we did this by calculating the disability adjusted life years, or DALYs. And so we calculated the total DALYs for the family. And for drinking water, we did a quantitative microbial risk assessment for 3 major pathogens: Campylobacter, rotavirus, and Cryptosporidium. And we used different boiling scenarios, and we calculated a family's exposure to pathogens from their drinking water. And for indoor air pollution, we used a box model to estimate the 24-hour PM2.5 concentration and corresponding DALYs. And we did this using different traditional and improved stoves. And we calculated a family's exposure to PM2.5 from cooking and water boiling. And we ran the model using a Monte Carlo simulation. And for our results, so this shows the benefit of boiling water, so the DALYs reduction, and the negative impact of boiling water, or the DALYs increase from boiling water. And so we did the model using the different stove types and our different boiling scenarios using log removal values. And here we have the benefit of boiling water, or the DALYs reduction. And here we have the negative impact of boiling water, or the DALYs increase. And we have the stoves in order of increasing PM. And we did 2 scenarios: a scenario in which a household was already cooking and they boiled their water on the same stove, and a scenario where a household was not cooking at all and they boiled only. And you can see that if a household is already cooking, the additional health risk is very small from boiling. But if we're cooking at all and then they start boiling, there's a really increased health risk. However, in most scenarios, the benefit of boiling water far outweighs the negative impact of boiling water from air pollution. Thank you. All right, now let's share. All right. So now we'll go ahead and take questions and also take voting. So I just made a summary. The first 6 presenters are participating in the competition. So if you just need a reminder of what their presentations were on, you can view the abstracts here. And then we have the vote for the People's Choice, the best presentation here. Hayden, are you able to put the Google form in the chat as well?
Yes, I can do that.
Okay, just in case the QR code doesn't work. We can go ahead and start with questions. So feel free to put questions in the chat, or if you're panelists, you're welcome to ask each other questions. So the first question from Jay, we have 2 questions. Is anyone doing research in perovskite solar cells and or solid state battery tech, which I'm actually not sure what those mean. So I don't know if anyone is doing research related to those areas. No.
Yeah,
Jay? Okay, go ahead. Yeah.
Yeah, so I have no idea about the first question, but for the second one, so I don't know if you're asking about the manufacturer aspect or the strategy aspect of the battery tech. If it's like how to use battery or how to take advantage of battery to integrate more clean energy, I think we have professors, at least in our department, CCEE, working on this aspect. But yes, so I think there are several projects on how to use the combination of storage and solar or wind to increase the capacity value of renewables. And also a project is working on how to use battery to meet the peak demand in different regions. Yeah, and yeah, that is all I know about the battery aspect. I don't know if I answered your question or not.
Okay, thank you. And I forgot that I can allow participants to talk. So we have a question from Dr. Vanadeep Kalavanganta. I'm sorry if I mispronounced your name. I'll just allow you to talk. Let's see, did that work?
Hi. So am I audible?
Hello? Yes.
Am I audible? Yeah.
Yes, you're audible.
Yeah, this is Vanadeep from the Department of Marine Earth and Atmospheric Sciences. So my question is about that IRTMS, the IRTEMS project, with regards to modeling the traffic in cities and at the ground level. So while building this model, since we know that traffic emissions or the concentration of pollutants that are emanated from traffic emissions have a great deal to do with the meteorological parameters and the atmospheric mixing, and the seasonal variation is quite evident. Anthropogenic activity coupled with meteorological variations will give us a clear picture when it is viewed in a broader perspective with the seasons and also the local factors, because every region has a different local factor. Influence, some burning of brick kilns or mining and everything. Like every region has its own stuff going on around. So while building this model, what are these parameters taken into consideration? And if yes, they definitely need a ground level measurement or satellite measurement. What are the types of measurements that you are taking? And what is the technique that you are using to continuously integrate the data and the simulation?
Hello. Thank you
Hi.
very much for your question. Really, really good one. So to understand a bit more about how it works, so this is a simulation system. So it's like a combination of different modeling tools to give at the end, like in this case, I guess you are mostly interested in the air quality part. So the focus of the EARTHM projects would be the part of the emissions of road traffic emission in order to prepare the emission results to integrate it into an air quality model. These kind of air quality models that we can feed with the simulation system would be the ones known as CFD models, computational fluid dynamics models. So these are the ones that would take into account all the meteorological effect, the transport effect, chemical reaction in the atmosphere, and so on. And yeah, they have their own requirements on meteorology inputs and so on. So the EARTHM projects would provide the emission data coming from the traffic. So in our case, the input would be like traffic related information, traffic volume, traffic intensity around roads, different vehicle fleet mix that you can have in a city, traffic demand, and this kind of input that would be introduced in a traffic simulation model that would be coupled after that with an emission model. The particularity of the emissions model are that in every country we use like different emission models related to traffic, because the information that feed these emission traffic models is different regarding the vehicles that are being analyzed and that are representative for each country. So, for example, here in the US, usually it uses the MOVES model, which is a traffic simulation model that includes several or different scales. In Europe, we are using different ones. There are the option of one that is called COPERT or FEM that are different. The resolutions are different. You can go from more detailed information or to get more high resolution like meters and second resolution to more bigger resolution like kilometers and hour resolution. And so on. In Australia, we have also different models that they are using. So the idea is to get a simulation system that take this into consideration, and at the end, get the emissions results that could be useful for feeding an air quality model. Yeah, I don't know if this is a good answer for your question. Or
yeah, it was quite good. I appreciate that explanation. My real focus was on the point that whether you take the emerging local factors which are unique to the given region while considering your model. That's the main emphasis, and you have given a very good explanation. It is pretty good. Thank you. Thanks a lot.
To explain a bit more this part of the input data, so this would be like we will be working together with the public administration in order to get the traffic information that we need. So, for example, traffic volumes and so on, and this would be particularly of each place that we analyze. So yeah, of course, for each part that you analyze, you will need the specific data for this region.
Yeah, this was what I was looking for. Right now, thank you, thanks a lot. And like, if I am permitted to ask the question, like with regard to the boiling of water, like, can I go ahead with the permission of the? Yeah. Okay. So the student or the person who just explained the benefits of boiling of water and versus this exposure to indoor air pollution, like what is the sample size and what is the research area? Like in which part of the world did you collect all these samples, and what is the sample size?
Okay, yeah, I should clarify. So this was completely a modeling study. The original idea was actually fieldwork, but then I worked on this project during COVID. So I used sort of existing, I did a literature review of existing data regarding boiling. So regarding the boiling effectiveness, I essentially tried to compile as many studies as I could to include in that. And then I focused on modeling two countries, Vietnam and Uganda, because both of these countries have significant rates of boiling. But it was a complete modeling study. So I only used the available data in the literature. We hope to do fieldwork at some point.
Yeah, I understand. Like I was looking for the regions. It is Vietnam and Uganda, right?
Huh? Oh, say
Yeah.
that again?
Yeah, it was the data was from Vietnam and Uganda, the households in Vietnam and Uganda,
Yes.
right?
But
One Asian country and one African country. Yeah.
yes. Yes.
Right.
But
Thank you, and I wish you all the best for your future endeavors. Thank you.
thank you. Yes. And I should make it clear in my presentation that it was modeling and not fieldwork. Thank you very much.
Yeah. That's where I felt like there was a little ambiguity. Thank you. Thanks a lot.
Thank you for asking. We have another question from the QA. It says, how does the artificial intelligence system know that the nuclear plant is degrading?
Hi, so we have been studying specifically piping equipment systems. And with past research, we know how degradation occurs in these piping equipment systems is using the flow-assisted erosion and corrosion phenomena that happens at nuclear power plants. And also past research has shown that this happens mainly at any discontinuities in the system. So in order to create an initial AI database, we need to do simulations where we assume degradation is taking place at these locations. And once we train our AI network with multiple simulations, when you give it a new set of data, it can predict where the degradation is supposed to be in this new set of data based on all the simulations that we have trained it on. And then when you go to a nuclear power plant and you have sensors that are installed on the nuclear power plant, these sensors give data continuously to our AI framework. And using this data, it corresponds it to its simulations that it has learned from, and then it can tell you where it has detected any degradation. And using this, my framework I have tested this for 3 different systems, and I'm getting accuracies that are all above 97%. I hope that helped your answer.
Thank you. And for the person who asked, if you have any follow-up, feel free to put it in the chat, or you can raise your hand as well, and I can allow you to speak. Yes, go ahead.
Hi, so I have one question for Amir. I feel like that we are doing very similar work. So the first one is, I'm wondering how you quantify the emission tax or emission penalty with a unit like dollar per megawatt hour.
So yes, it is the dollar per megawatt hour. What we are using is that, so we use the EPA data for the emission from each power plant. And we used AP3 data that was provided us with our colleagues in UNC. They converted that emission rate into emission penalty for each power plant. So that's basically the amount of that health cost of each power plant. So we are adding that as a tax penalty for each power plant. So our UCED model is adds that penalty as a cost.
Got it. Yeah, so we are really doing very similar work. Maybe we can add up. Yeah,
sure.
But the second question is like, how did you quantify the ratio inequity? Because I found that you used a coefficient between the ratio inequity and the health burden.
So again, that's the part that our collaborators at UNC provided us. What we have, so we have the amount of emission from each power plant. We gave them the emission numbers, and they provided us the racial inequality coefficient. which I'm not really familiar with. It was a number between 0 and 1, and the bigger the number, the higher the inequality. So I think they use the location of each power plant and then the demographic of each county. Using those data, they were able to provide us the racial inequality number.
Cool. Thanks for the explanation.
No worries. I'll be happy to chat, or you can feel free to contact me. So I would send you my email address so you can easily find me.
Okay, thanks.
I think it's 10 till, so I think maybe the easiest thing, if any of the attendees would like to join the panel to speak directly to our presenters, just go ahead and raise your hand on Zoom, and I'll transfer you over. And then while you're doing that, we can take any more last questions anyone has. So if any of our attendees would like to be made panelists, and we'll stop recording then just so you can meet the presenters, just raise your hand. Meanwhile, does anyone have any last questions? You can either put in the chat or in the Q&A, or raise your hand. I can unmute you to speak, or and also the panelists can feel free to ask each other questions as well. And then, of course, one last reminder is that we will be emailing the results from our competition. I guess, Chan, I have a question. I guess, so based on your study showing sort of the inequalities of these, like, I guess, what are sort of the next steps? Like, how can we, like, what can we do? Because I know there's a big push even for even I say like cooking. There's a big push for even like using electricity for cooking versus gas, because it's perceived as so-called like healthier in the home. So I feel like there's going to be more and more push for like higher electricity loads. So how can we kind of balance the negative impacts on some people while also trying to promote electricity, if that makes sense?
Yeah, so for this project, I don't know like how to reduce the disparity, but if we look at the number of mortalities associated with electricity generation, actually clean energy or adding carbon tax can help reduce like 80 to 90% of the total damages. So if we only look at the total numbers of damages, like using clean energy can definitely decrease the number significantly. But for the inequity across demographic groups, I don't think I have a good answer now, but I attended some similar before, and the professor also did a similar work, but based in California. So he estimated the inequity caused by different sector, and his answer is that I don't think it makes any sense, but his conclusion is that let people move from that place, because the hotspots of the pollution is mainly in the city centers. So if people can move from city centers to urban or suburban areas, maybe the disparity can decrease.
Thank you very much. Let's see. Oh, we have a question from attendee. Yes, go ahead.
Hello. So my question is about this safety for this nuclear piping systems. So we have these nuclear disasters, like we had 5 worst nuclear disasters with respect to Chernobyl and Fukushima and everything. Like the system that you are working on, the AI system that you are working on, Like, were you able to test its or evaluate its effectiveness in real time anywhere, or is it just in the developmental stage? And one more thing, can we extend it to because recently we have seen a gas pipe leak and power shortage, that fuel shortage for so many 12 or more states in the East Coast. So can we extend this type of AI mechanism to detect or prevent even leaks in some other systems?
Okay, so for the first question right now, yes, this is a proof of concept developmental study where we are simulating data, because in nuclear industry, you don't have access to real sensor data unless you can prove that you have a working simulation model. And after that, we also have to supplement it with experimental data from our own lab. And currently we're setting up that system and everything in our lab. So once that is done, we will be able to access, or rather apply for permission to get access to nuclear industry data. And then we'll be able to do it for a real nuclear plant. However, in our simulations, we have used designs of real nuclear power plants. And for your second question, yes, I believe this can be extended to gas pipelines and other kinds of utility pipeline networks. There are also a lot of AI frameworks that already exist for those kind of piping systems where they measure pressure changes rather than in nuclear systems where we measure acceleration versus time data. So we have discrepancy in what needs to be measured and how those systems behave with respect to nuclear systems. But I think it can be extended to that as well.
So what is the efficacy like? What is the rate of effectiveness of your whatever the AI, like what is the percentage of that?
So with my, I tested it on 3 different systems, and for all 3 of them with different loading scenarios, I was able to get more than 97% accuracy, which is much higher than what the other existing frameworks have done till now.
This is a very significant research in my perspective. 97% is something really extraordinary. Were these tests or whatever were conducted under laboratory protocols, or is it like in the net ambience that is found in the nuclear plants? Were your experiment? Yeah, please go on.
The laboratory experiments will not be done in the nuclear environment right now. The first step is to get it in the regular environment, and then after that, we do have capability in our lab to extend it to nuclear protocol environments as well. So
one last thing, like, do you expect this efficacy, the effectiveness to spike or go down when you test it in real time? What's your assumption?
I'm going to assume that it's going to have at least maybe 2% or 3% drop because of noise and other kinds of vibrations that are included in real life scenarios.
Thank you. Thanks for the explanation. I appreciate it. All the best.
Thank you.
Thank you very much. Does anyone have any last questions? I guess I have a question for Matthew. Matthew, I'm not as familiar. I don't have a strong materials or mechanical or solar background, but I was just curious with these stress tests. So I guess so you're studying the stress of these different materials. So I guess when the solar panels are in use, like what in sort of real life can be causing these stress over, and like how can we extend sort of the lifetime of these solar panels?
Yeah, that's a good question, and that's kind of what we were trying to figure out. So it goes anywhere from just when they're being installed, right? Like you have people moving them around or transportation, so there's kind of mechanical jolting of them from that. Heavy snow actually can cause issues like that. there are a lot of instances where like birds will start like landing on them, or just like goats or something. There's a lot of like different situations where they could be experiencing some stress and they'll prematurely break. So that's why we're trying to get these strain gauges inside so that we can actually measure it real time to see and better design, I guess, what they would be like in the future.
Okay, cool. Yeah, thank you. That's really interesting work. Yeah, I was a Peace Corps volunteer in Liberia, and our school had solar panels, but we had this major issue where like they didn't have money. The solar panels were donated by a nonprofit, but then the school didn't have money to like replace any of the parts. So it was just like, you know, like it was just like over time they got worse and worse and worse, and then they were just like, we can't fix it. And so it'd be really anything to sort of like extend the lifetime, I think is really cool. It can create some of these projects, make some of these projects much more sustainable. So I think it's cool.
Yeah, and the next one that we're kind of working on is looking at hail impacts of them, because if we want them to last for 20 years, they're going to experience at least one hailstorm, depending on where they are. So it's kind of the next one.
That's really cool. Thanks. Does anyone else have any question? I have another question, but I want to make sure we give the attendees and other panelists a chance to ask first, and then we're almost out of time. And I think it's 3 o'clock, so if you need to leave, feel free. I just wanted to ask Shamik a quick question. Shamik, are you there?
Yeah, I'm still here.
Yeah,
Sorry.
I was curious about, so you said this project about carbon offsetting was a class project, and I was just curious, like, what are the next steps? Like, is this something you plan to continue working on, or?
So this was actually a midterm paper that I wrote, and so we basically had to choose a topic. I don't know how to the next steps would be, but I'd be interested in, I guess, planning that step. Like in my head, you know, what would the next step be? And that, I mean, that's all I can really answer since it was just a paper. Yeah.
Really interesting. It's cool you're doing that work. So.
Thanks.
So I just want to take this time to really thank all our presenters. You all did an amazing job, and it was really, really cool seeing the diverse energy research from across NC State campus. We had a lot of different departments represented, and we really appreciate you sharing about your research, and we hope that in future events, we can have you present again. It would be great to see how the research evolves. And like I said, it sounded like a few connections came. So I don't know, are you all comfortable if I kind of like share each other's, I guess you already have your names, but if, can I share your emails? Would that be okay with you all in case anyone wants to follow up? And like, yes, go ahead, Harleen.
Oh, I'm sorry, I thought that was a thumbs up.
Oh, okay. Yeah, so unless if you have a problem, just send me an email. But I was thinking, you know, like maybe later today, I'll try to send each other your emails. So in case you want to make connections, but I really want to say a big thank you. And we will, it usually takes us, sorry, we're a little slow. It takes us a few days to get the recording up. But as soon as we have the recording ready, we'll share with you in case you want to share with others. And we should hopefully get the results out soon, either like later today or early tomorrow. So thank you again. If you have any other questions, please ask. And Dr. Vandadeep, I just really want to thank you for your participation, your really excellent questions. It was great.
Thank you. It's been so informative, and it's my pleasure. Thank you.
Yeah, thank you.
And keep the great work up in the future. Thank you.
Thank you. All right. Yeah, if nothing else, thanks everyone. I'll hang on a little afterwards in case you want to chat about anything. So
Thank you very much.
Thank you. See you guys.
Thank you. Bye.
Thank you. Bye.
Thank you, everyone.
thank you.
Emily, are we staying on or?
I think everyone's leaving. I was just going to hang out in case anyone had any concerns, but I don't think so. Feel free to go. I'm just making sure.
Oh, okay.
Yeah.